solving equations, the equations are either going to have a radical in them, or you'll have some parentheses and then a rational exponent. So you have to remember that rational exponents and radicals are the same thing. They're just written in different ways. Okay? So the first one has a square root in it. Your first objective in order to solve for x is to get everything away from that square root. So if you look, we have a little 3 here. We don't want the 3 there. We want it gone because we want to isolate x, and we can't do that if there's stuff near x. Yeah?
Do you have a pencil on it? Thank you.
Alright, so we're going to get rid of this 3 by subtracting it because it's positive. So we're subtracting 3. So that gives me the square root of 2x minus 3 equals 5. Okay. Now once you have the radical or whatever it is, rational exponent, by itself, you're going to get rid of it using different techniques, okay? So since it's a square root, the index is 2, you're going to square both sides to get rid of the square root. So you're going to square this, and you're going to square this. When you square something that's square rooted, those two are inverse operations. They will cancel each other out, just like square rooting cancels out squaring. So you have 2x minus 3, and then over here 5 squared is 25. And then the rest should be really easy. Right? So how do we solve this?
Add 3, and then
Add 3. And then after that?
Wait, why is
Wait,
it
it's
22?
22.
It's 28.
Yeah.
It's 14.
It is 28. It is 28. Sorry, I guess I subtracted it in my head. Ew, that's ugly. Yeah. And then you get 14. Okay, and you want to check your answers for these because in certain questions we can get extraneous solutions. So not necessarily here, but in some of them. So you're going to go back to the original and you're going to plug in your answer. And then basically just simplify the left side of the equation, simplify the right side of the equation, and then see if they're the same. So we would do like inside out here. So 2 times 14 is 28. 28 minus 3 is 25. This is 5. And this is 8. Is that true?
Mm-hmm.
Yes. Okay, so that means that this is the answer and it's not extraneous. If you have one answer and it doesn't work, what's the answer?
No solution.
No solution. You can get no solution for these. You get no solution sometimes because, let's say you have something like this. Okay, so when you square root things, you can't get a negative number. So this would be something that's no solution. Okay. So you do want to make sure you plug your answer back in. If it doesn't work, then you have no solution. If it does work, then that's your solution. You might have 2 like answers at the end, and then one will work and one won't. Or maybe they both won't work. It just depends. Okay. All right. Questions on that? Okay. Let's go to the next one, which has a 2/3 power in it.
That's not fun.
It is not fun. These, I would think, are a little bit harder than the last ones.
So I'm just making sure you skipping the try.
I'm going to go back to them at the end.
Okay.
Yeah, so skipping the try for now, we'll go back to them at the end. All right, before you do anything with the question, what you're going to do is rewrite this part so that it looks like a radical instead. That way it'll make sense as you're solving the problem. Right now, 2/3 power doesn't really mean anything to me, so I need to rewrite that as a radical. So I have 2 times x plus 3. Actually, I'm not going to put the parentheses there. I'm going to put it around the whole thing. So 3 is the index, and then 2 is the power. But I guess you could rewrite them the other way. I just prefer to do it this way. But you can do it the opposite way if you want. I just think that this way the numbers are smaller. If you do it the other way with the squared inside, the numbers will get a little bit bigger, which is, you know, not ideal. Okay. All right, so we're going to start the way we started the other one. We want to try to isolate x, so get everything away from x that you can. So
Add one,
probably add 1 first.
and then did you divide by 2?
So when you add 1, you get 8. And then there's gonna be sometimes a number here. If it's a number like 2, like a whole number, then you're gonna divide it. If it's a fraction, you can multiply it by the reciprocal. So if this is like a 1/2, you can multiply both sides by 2. Okay, in this case, we're just gonna divide by 2. So you get 4.
You get 4.
8 divided by 2 is
Oh,
4.
I'm looking at the 2, okay.
Oh. Okay. Now, everything is away from the radical, right? Except the radical and the fluffy stuff around it. So now we're going to get rid of the squared. So what's the opposite of squaring something?
Divided by
No, it's like multiple.
Subtract, no.
Square root.
Square rooting.
Uh,
Okay, so you have to remember, like way back in chapter 4, when we square root both sides, that's called the square root property. Okay, so we're square rooting both sides. Remember that whenever you square root both sides, to solve an equation, you have to include a positive or negative scenario. So you're not just gonna square root 4 and get 2, you're gonna get positive and negative 2. Now that gets rid of the squared part, but it's not getting rid of the cube root part. So you can't get rid of the cube root part yet. Okay, so that just gets rid of the squared. You're only gonna put the plus or minus when you're square rooting both sides. You don't put the plus or minus when you're squaring both sides. So in number 1, we squared both sides, we didn't put a plus or minus. That's not the square root property. So when we square root both sides, we put the plus or minus. Okay, now we're gonna do something to get rid of the cube root. So what is the opposite of cube rooting something? Cubing it. So we're gonna cube both sides. You're gonna get 2 things here because we have positive and negative 2. So 2 cubed is 8, right? And negative 2 cubed is negative 8. So you're gonna have plus or minus 8. Now, it's up to you if you wanna write this, like if you wanna separate it like this. Okay, but you don't have to if you don't need to. But essentially, we should get 2 answers because of the plus or minus. So when we subtract, so last step is just to subtract 3. We should get x equals 5 and x equals negative 11 as your 2 answers. Then you want to make sure that you go back and you check those. Okay, so before we check it, let's just kind of recap. Very first thing you want to do is rewrite this as a radical so that you know what to do with it later. Because if you don't really know what to do. Try to get everything away from the radical. Okay, and then you're going to get rid of the powers like 1 at a time. So you'll get rid of the radical and you'll get rid of the power 1 at a time. Don't try to do it all at once. It can get confusing. Okay, and you should get 2 answers for some of them, not all of them. Okay. So checking your answer, I'm gonna check the answer in the one where it's rewritten. So I didn't like do anything to it, just from here to here I just rewrote it, okay? So it's not a different equation, it's still the original equation, it's just rewritten. So we'll plug in 5. So when you plug in 5, you get 5 plus 3, which is 8. Okay, the cube root of 8 is 2. 2 squared is 4. And 2 times 4 is 8. And this is true, right? Okay, so this one works. Now, your calculator does this too, but you need to know how to do this by hand for the quiz. But on a test, if you just plug in like this part, it'll tell you 7. You just have to know how to do it. So I would just practice that on your homework tonight, plugging stuff in. Let's plug in negative 11. So negative 11 plus 3 is negative 8. Okay, the cube root of negative 8 is negative 2. But negative 2 squared is positive 4. So the rest is the same. So that one's going to work too. Ta-da. Alright, so we have two solutions and they both work, so we have two answers. Questions? Are you sure? Positive. Okay, last one. I don't know if this one's harder than the last one, but it's definitely harder than the first one. It involved a little bit extra work, and that's because if you look, there's another X in there. Okay, so obviously, like the more stuff I put in the question, the harder it's going to be. We still want to start the same way. So what would we start with here?
+1.
Right. We want to isolate the radical. Now, when we add 1, you can't combine 1 and x. They're not like terms. So you're just going to write x plus 1. Okay, if that was a number, if it was like 3, then you could just add them.
Wait, Mr. I have a question. So you know how like when you have the parentheses and have like 2 to the x plus 3rd?
Yeah.
And you do the square root?
Yeah.
Can't you just like do like 2x plus 3 or no?
No, because you're squaring it,
Like
not
you
multiplying
can't
it
do
too.
that?
No.
Okay.
Because look, so PEMDAS says you have to do the exponent before you multiply.
Yeah.
This would be multiplying before the
Yeah,
exponent.
gotcha.
So if this exponent wasn't there, then yes, you could do that. But
Okay.
since the exponent's there, you can't do that. Not a bad question, actually. Okay. So like I was saying before, they're not like terms, so you can't combine them. So don't write like 1x or 2x or any of that. Okay? Now, after this, we usually do what? We square both sides because it's a square root. If it's a cube root, what would we do? Cube it. Okay, it's not a cube root, so we're just going to square both sides. And this is where it's going to get a little bit harder than number 1. Okay, when you square a binomial, you have to FOIL out 2x plus 1s. You cannot just square the x and square the 1. That's not how this works. Okay? You can only do that if they're like multiplied. You can just like square each one. When they're added, you can't do that because it means 2 multiplied together. So x squared plus 1x plus 1x plus 1. Okay? And then there's the shortcut. Yeah. So the shortcut is
Like 1 plus 1 is 2.
no 1 times 1. We're multiplying.
Alright.
Yeah. 1 times 1 is positive 1. You're multiplying.
I thought you added it, that's the reason.
You add them at the end. The shortcut is to take this guy and square it. Then you can double both of these together. So what's double 1x?
2x.
And then square the last one. So what's 1 squared? 1. Okay, that's what I got over here, just simplified. So that's the shortcut if you want to use the shortcut. Otherwise, just make sure you FOIL them both out. Now over here, this is going to cancel out the square root. You should be left, so if you have 2 x's in the problem, typically you should be left with something quadratic. Like if 1 was just kind of a free willy-nilly x, because when you square it, he's going to be squared. So you're going to use some sort of technique that we learned in chapter 4 to solve the quadratic equation. So AKA, you're either going to factor, complete the square, or use the quadratic formula. Okay, but before we do any of that, everything has to be on one side and you need it set equal to 0. Okay, so how would I set this equal to 0?
X plus 3x
Minus
minus 4.
minus 5 minus 5.
Right. So subtract 5 and add x.
Log x squared plus 3x minus 4.
Now, sometimes it'll factor, maybe it won't factor, maybe you'll use the quadratic formula regardless because you just don't like factoring, whatever. Okay, but you do need to know how to factor for the midterm, so don't think you can avoid it forever.
-1 and plus 3.
So,
This factors.
what you're saying is for the midterm, we're gonna get that Christmas bonus.
Christmas bonus, yes, you do get a Christmas bonus. What multiplies to -4 and adds to 3?
-1 is 1.
Yep.
Okay, when I hear that Christmas bonus coming around the corner.
After you factor, what are you supposed to do with these?
Oh, set them to 0.
Sum to 0 and get the solution. So,
Okay, x equals 1, x equals -4. Come on
Right.
now. I know how to factor. Come on.
do you... Okay, so we got 2 answers. What should we do?
Set it back in.
Plug them back in and check. Now, sometimes people check wrong. when you check your answer, like you're plugging it into the original, and all you're doing is just math, and then see if they're the same. Don't solve the check, okay? So the original equation is 5 minus x in the square root minus 1, and then equals x. So let's check the number 1. So I'm plugging in 1, and I'm plugging in 1. So you're gonna math, and see if it's equal to the right side, which is 1. So 5 minus 1 is 4. The square root of 4 is 2. 2 minus 1 is 1. Are those equal?
Yes.
Yes. Okay, so that means that is a solution. That one worked.
Bless you.
Gotta love solution.
Let's check the other one. The other one's negative 4.
Bless you, isn't it? No.
Okay. 5 minus negative 4 is 9. The square root of 9 is 3.
It's not gonna work. Wait.
3 minus 1 is 2. Are these the same?
No.
No. So this one doesn't work. It's extraneous.
Oh, so we really gotta check out right now.
You really do.
I was about to say, what if I just know I'm right?
I mean,
You can always just take a chance.
Right, I'm chilling.
I would say the ones that you really want to focus on checking are definitely the ones that, like, you're solving a quadratic, but sometimes even the easy ones can be no solution. And so you'll just like do the math and get a solution, and you shouldn't have gotten a solution to begin with. So for example, something like this,
Or you won't do the math and just like guess.
something like this doesn't have a solution because there's no number that you could plug in here that when you square root it gives you a negative, right? Square roots are always positive. So this would have been no solution. You would have probably gone through all the steps to solve it and like wasted your time. So that's why you should check it just in case the original question didn't have a solution to begin with and you just kind of like did math and didn't pay attention to that. Now, the other, so if you look at the first you try, it has a cube root on it. The cube root ones tend to not have extraneous solutions because remember, things that are cube rooted can be both positive and negative. So there aren't really domain restrictions. The ones that tend to have extraneous solutions are square roots or fourth roots or like even roots. Those are the ones that tend to have extraneous solutions because they have domain restrictions. The square root thing can only be positive numbers. So if it's like a cube root or something, you probably don't need to worry about it too much. But when it's a square root, that's when you have to worry about it. All right, so now we can do some